Everyone, welcome to my channel. Today I want to discuss making a kaleidoscope effect in Three.js with JavaScript. So let's jump right in. The way we're going to do this is to create what's called a buffer scene and a render target. That render target is where we'll take this icosahedron and the rest of the scene, render it to that render target. We'll use that render target as a texture, and we'll lay it out on a bunch of polygons, triangles actually, and array those triangles into hexagon shapes, and then tile those hexagons, and it ends up looking a little something like this. Okay, I've got this icosahedron just moving back and forth, right and left along in the scene, and then I've put it on all these different triangles to get this effect. It'll hopefully become more clear as we go through, but let's get started. I've got a Three.js scene where I've set up my renderer, added an icosahedron and just a simple normal material, put that in a mesh and dropped it in the scene. In my animation loop, which is called as often as possible using the request animation frame API, I'm updating that ball's position. In this case, I'm just rotating it and then rendering. Okay, so what we're going to do is a couple of things. We're going to create that buffer scene in the render target, and then we're going to put this rendered result onto that plane. So let's see how to do that. Let's set up the buffer scene first. Can you see my eyes darting over here to see my notes? That's what I'm doing. I'm going to create a new buffer scene. The size of the scene is 512, and cost buffer scene equals new 3.scene, and it's that. And const buffer camera is equal to a new 3.perspective camera. We need the field of view 75. I do want to play with that to see what kind of different results we can get. The aspect ratio will be the size by the size because we have a square render. That's the near and that's the far. Let's move that buffer camera back a little bit. Oh, I said buffer again. Whoops. Position z equals 5. And when I said back, I mean actually toward the viewport. Lastly, I'm going to const buffer render target equals new 3.webgl render target, and we're going to pass that render target our sizes. Okay, good. Everything's good so far. Instead of adding this ball to the scene, I'm now going to change that to add it to the buffer scene instead. And bye-bye, now it's gone. To see it again, let's create a view. That view is just going to be plane geometry. So that's debug plane, let's call it. New 3.plane geometry. Let's say it's 3 by 3 by 3. That's probably going to be too big, but whatever. We'll see. meant to call this debug geo. Debug mat is equal to a new 3.mesh basic material, and we're going to pass in let's start with just a color is equal to 0x red, and our const debug plane is equal to a new 3.mesh. It's taking our debug geo and our debug material like that, and then we scene.add debug plane. So we should see a red rectangle, a red square right in the middle of our screen. We have successfully created our plane. Let's change that from a color to map is the buffer render target dot texture. Okay, and it's black now. Do we have any errors? I don't think so. No errors, but no result either, and that's because we didn't render this. We didn't render our buffer scene. Let's do that. We have to do something special with the renderer here. We have to set the render target to our buffer render target. Thank you. Thank you, autocomplete. And then we need to render it. Renderer.render, and we want to render the buffer scene, I think. And we'll use the buffer camera to render the buffer scene. Okay. That's still not enough. If I save that, we broke it. We need to set the renderer dot set render target back to our default scene. Good. Just for a little contrast, let's set the scene dot background to a new 3 dot color red. Okay. Now we can see our square, and it's empty. But why? Why is it empty? I'd like to know. WebGL. Oh, 3D render target. That doesn't look right. That looks a little bit better. Okay. I had mistakenly created a WebGL 3D render target instead of just a WebGL render target, and that caused this to fail. Let's increase the size of our ball a little bit. Yeah. Next thing we'll do is set up a listener to show and hide the debug view, and then we'll create a bunch of hexagons to render this to. Let's get started by hiding the plane. We can simply set its visible property to false, and that's easy, but we also want to be able to show and hide it. So I'm just going to create this key up listener, and we'll call this handle key up, and I'll create that handler, and it gets an event, and inside that event we just want to listen for key, a specific key being pressed, the spacebar. So we'll say, hey, if that event.key is equal to space, then do something. In this case, toggle the debug plane visible property. We're just going to put a bang in front of that property. And now inside the viewport, if I tap the spacebar with it, it will show and hide that plane, that debug plane. Cool. Let's get started by creating that hex. This will be the meatiest part of this video. Let's put it right above the debug plane. We're going to need two methods and a for loop. The methods are get try. Each hexagon is composed of 6 triangles, so we'll make them individually and passing an index parameter. Also a get hex also takes an index. Okay, and a for loop for let I to equal -1. We're going to start with -1 in this for loop. While I is less than 6 and I plus equals 1, we're going to scene.add get hex and pass it in that index. Okay, let's get these returning something. In this triangle view, I want to create a triangle geometry, or tri-geo. That's a new 3.circle geometry. And that's going to take a radius, which will make 1, and a number of segments, 3. Because we're guessing at 3 segments, it's not a circle, it's a triangle. Let's do const try material is equal to new 3.mesh basic material. We're going to give it options object inside which will have a color, and that's going to be a new 3.color. And we're going to set its HSL method to a hue that we're going to define saturation, which is just 1, and lightness is 0.5. Real quick before we go on, let's just create a hue variable and say that it's 0 for right now. One other thing inside of this options object that we're passing into the triangle material is side. We need to define this as 3.double side. What that means is, in general, in most, I don't know about most, in Three.js, when you create a mesh out of whatever, in this case I'm using a primitive from Three.js, it only has one side. It's rendered, that circle will have a front face, and then the back face will not be rendered. We're telling with this option, render both sides. Const try equals new 3.mesh and pass it our try geo and our try mat. Okay, and then return that. And for now, in our get hex, let's return get try and pass it that index. Even though we're not really using that index right now, and if I save, we don't see anything. Let's see if there's any errors. But there are no errors. I wonder why. Try is the mesh. It should be visible. Hue is 0. You know why we don't see it? Because it's the same color as our background. So there's our triangle. Actually, there's 7 triangles. You don't believe me? If I said try.position.x equals 0.1 times index, and we'd see 7 triangles. I think 7, yeah. 7 different triangles. Map.random. No, they're all different colors. Anyway, I didn't really want to do map.random. That was just a fun aside. I really want to rotate those triangles around a point in the middle so that they're oriented into a hexagon. To do that, I could do some math to figure out exactly how to rotate them, but I'm going to take the lazy person's approach. I'm going to create a try holder, new 3.object 3D. Okay, that try holder is a group in which I can move objects inside it. I can put an object in there, move it around, and then orient it the way I want it. Here's what that looks like. The position.x equals -1. Okay. Try holder dot add try, and now return that try holder. Not very exciting until I want to rotate that triangle too. Or actually, I'm going to rotate the try holder. Try holder dot rotation dot z. The z rotation is this axis here, so anything that orbits around that axis is equal to half a circle, math.pi, and I want a third of a half of a circle. Math.pi divided by 3. Okay, but I want that for each index times index. So when 0 comes in, it's 0. When 1 comes in, it's a third of math.pi, and so on. And then we get this. We go back to math.random so that we can see our different triangles. It's like that. Another fun way to handle this is say, let's give them alternating cues. So just for debug purposes, if the index mod 2 is equal to 0, then it's 0.33. Otherwise, 0.66. So, yeah. If it's 1 mod 2 is equal to 1, that's not true. It's this blue color. Okay. Otherwise, it's the green color. So even numbers are green, odd numbers are blue. Just for debug purposes. If we want to already see, and we do, we want to see our kaleidoscope working already, let's have a look at this. Let's say map is equal to our buffer render target dot texture. Okay, now we're using, let's comment out this color. We're now using that render target as a texture on these polygons. Isn't that nice? We have a problem. It's not quite looking like, let's see, 4A. It's not quite looking like this, is it? In fact, they're just repeating. And to fix that, we want to flip every other triangle so that we see like a mirror of it. That's why we need the double-sided property. To flip it, let's use that same trick we did with the index mod 2. And we'll say, this time it's rotation. Rotation.x is equal to math.pi, a half a circle, times index mod 2. There you go. It's a little more clear if I move that ball around a little bit too. Ball dot position dot x equals math dot cosine t times 0.002 or 001 times radius. Actually, I'll just give it a value of 3 and get a semicolon in there. Now it's sort of oscillating back and forth. If I enable the debug screen, see, it kind of slides back and forth inside the viewport. We can make that a slightly broader movement, like that. Okay, we're cooking right along. The last thing I want to do is to duplicate that hexagon and lay it out all around the screen so it looks like a proper kaleidoscope. And so in this getHex method, instead of just returning this triangle, I'm going to return 6 of these. So I'm going to create, right now all I'm doing is creating 6 triangles. I'm going to create 6 hexagons instead. So in each get hex, I'm going to create 6 triangles. That looks like this. For let I equal 0 while I is less than 6. I do plus equals 1 because I like instead of plus plus, I plus equals 1 instead of I plus plus, because I like Douglas Crockford, and this is his suggestion. He says that plus plus is kind of just bizarre looking. You do you. I'm going to create a holder for this. Const try holder is equal to new 3.object 3D, and that try holder is going to hold these. Try holder dot add get, and I don't want that to be index anymore. I want it to be I. Good. Now I've got a try holder, and I can just return that try holder. Now there should be 7 of those hexagons stacked up on each other. Try holder dot position dot x equals math dot random times 3. Whoops. Kind of like that. Isn't that interesting? Times 3 minus 2. Cool, right? Okay, but that's not the effect we're going for. We want them laid out in a circle. Whoops, sorry. So we don't need this position.x thing. We will actually. We're gonna to get the effect we want. We're gonna calculate the x and y position of the top right, middle right, bottom left, middle left, and top left. To do that, we'll calculate an angle. Say const angle is equal to math.pi again. Again, we want 1, 2, 3, 4, 5, 6 divisions of pi. Divided by 3 times index. That value is going to move from -1 to 6. Now the try holder dot position dot x is equal to math dot cosine angle times our radius. We didn't define radius yet. That's easy. Const radius is equal to 3. Play around with that value. We can do that later too. The position dot y is equal to the sine of that angle times the radius. Look at that. It looks perfect except for this giant red hexagon in the middle. That's because there's no hex in the middle. To fix that, that's why we're starting with -1. We're going to say, hey, if the index is equal to -1, oh, sorry, not equal to, then move them. Otherwise, don't move it. Oops, I forgot a curly brace. So now we have one in the middle as well. And we've completed our effect. In the interest of time, that's it. We're done for now. Play around with the different types of objects to put in the scene. Play around with this lovely thing here. Oh, you, by the way, just uncomment the color and you get like a kind of tint effect. Try this too. Why? No, not on this one. On that, the ball material, this mesh normal material, this can take a wireframe property, and then you get this cool effect. Isn't that lovely? Whoops, that didn't work. It doesn't want me to comment that out. That's all for today. Thanks for tuning in. And let me know in the comments what you think. Let me know if there's something you'd like to see in the comments. This video is the direct result of a comment left by a viewer. Thank you. Keep them coming. Thanks, everyone. Bye.